Let's take a look at the exercises for chapter 4, starting with the multiple choice questions. In regression, the variable being predicted is usually referred to as the dependent variable. A graph used in simple regression analysis often is called a scatter plot. In the regression equation, y is equal to 21 minus 3x, the slope is always the one that accompanies the x variable, and you always want to make sure that you include the sign with the slope, so the correct answer would be D. The following scatter plot indicates when we have a scatter plot that looks something like this, we see that the points are close to each other. They follow an upward direction from left to right, so this indicates a positive relationship, and in this case it would be a positive, strong relationship. In regression analysis, R is also called R, as we mentioned before, is the coefficient of correlation. The coefficient of correlation must be, the coefficient of correlation takes values from -1 to +1. For a data set, the regression equation y is equal to 21 minus 3x. The correlation coefficient for this data must be negative, and the reason being that the slope and R have the same sign. So if your slope is negative, your R, the correlation coefficient, will also be negative. The coefficient of correlation for a problem was calculated to be 0.36. The correlation coefficient is R is equal to 0.36. The coefficient of determination for this would be what? So we have R, and we're looking for R squared. All we need to do is 0.36 squared. So in this case, this would be 0.13. You square the R, which is 0.36. A regression model was developed, and the intercept was 21.4, while the slope was -0.4. For this, it can be determined that the coefficient of correlation will also be negative. If the slope is negative, R will also be negative. If x and y in a regression model are totally unrelated, if they're totally unrelated, that means that the coefficient of determination will be 0. If x and y are totally unrelated, that means that R is equal to 0, and if R is equal to 0, R squared will also be equal to 0. So let's look at this problem. The following information regarding a dependent variable y and an independent variable x is provided. You have your x and you have your y. When you enter your data in your graphing calculator, this will be your L1, this will be your L2. Keep in mind, x is always L1, y is always L2. If you were to use the graphing, if you were to use the equations, you would need to create a table like this one, where you have your x, your y, x times y, x squared, y squared. At the end, you calculate all the summations, and then you plug in the formulas for the slope, the y-intercept, and then the equation that links the two variables. Now, let's see how we would do it using our graphing calculator. Stat, enter. You have L1 and you have L2. You have L1 and L2. Once you enter your data the right way, you go to stat calc number 4. So this will be the information required for the problem. I'm asking for the y-intercept, which is the b. The y-intercept is equal to 2. I'm asking for the slope, which is your a. Your slope is 1. And the equation is y is equal to ax plus b. In this case, it would be 1x plus 2. Now, we are asked to predict the value of y when x is equal to 4. Now, first thing you'll do whenever you have a question about predicting the value of y when x is equal to 4, you go back to your table and you try to see if 4 is within the range of your x values. X minimum is 1, x maximum is 5, 4 is within that range, so you can predict the y given the x value to be 4. We know that the equation, the y predicted, the y with the little hat on top, is equal to 1 times x plus 2. This is the formula. So this would be 1 times 4 plus 2, which would indicate that the y predicted will be equal to 6. So when x is equal to 4, the predicted value will be 6. Calculate the coefficient of correlation and explain its meaning. Does a linear relationship between the two variables exist? So, if we were to use the formulas, you already have the table from the previous question. You plug in the numbers and you find that r is equal to 0.791. You also have that information. Let me just adjust the lighting so you're able to see it. From your graphing calculator, r is equal to 0.79, which indicates a strong positive relationship. Now, we want to find the coefficient of determination, r squared. We already have it in using our graphing calculator, is 0.625. If you didn't have it, you could have just used r. Let me just, sorry, I have to go back and forth, but based on, so you guys will be able to see the graphing calculator a bit better. We want to calculate the coefficient of determination. There are two ways. You either look it up on your graphing calculator, or you simply take the r value and you square it. 0.791 squared, this would be 0.625. 0.625, if you were to interpret it, you would say that 62.5% of the variability of y could be explained by the variability of x. By the variability of x. For the second problem, the following information regarding a dependent variable and an independent variable is provided. So we know that the dependent variable is the y and the independent variable is the x, which means this is going to be your L1, this is going to be your L2 when you enter the information in your graphing calculator. Once again, I'm asking for the y-intercept, the slope, and the equation that links the two variables. Using the formulas, you have access to the table, x, y, the product of x and y, then another column for x squared, another column for y squared. You make sure that you calculate the summation of each column and you substitute in your formulas. Be very, very careful with your calculations. If you were to use your graphing calculator, stat calc, actually no, we have to enter them. Stat, edit, L1, L2, I already have the numbers in. Stat calc number 4, and this would be, you would have access to all the information required. You have the slope, A, 2.5435. You have the y-intercept, 12.1957. You have the correlation coefficient, r, and the coefficient of determination, r squared. So all the needed information is in this screen right here. So the formula based on that would be y is equal to 2.5435x plus 12.1955. Now, I want to predict y when x is equal to 14. That's the next question. Predict y when x is equal to 14. You go back to your original data set. You check for x minimum, which is 3, x maximum is 12. Notice that 14 is greater than the x maximum. Therefore, we cannot predict for x equals to 14. It's outside the range. Outside of the range. X equals to 14. Calculate the coefficient of correlation and explain its meaning. Does a linear correlation relationship between the two variables exist? So, if we take a look at this, we already have R. R is equal to 0.9993. So obviously we have a strong positive relationship. If we want to check for a significant, if there is a linear relationship between the two variables, we would have to take R. So R is equal to 0.9993 and compare it to the critical value for the table you have in your notes and the PowerPoint slides. So in this case, we have 4 pairs of data. So n is equal to 4. N is equal to 4, which means that the value, the critical value, is 0.95. So R is greater than the critical value, so there is a significant linear relationship between the two variables. Now we want to calculate the coefficient of determination and explain its meaning. We already have it in our graphing calculator. It's 0.9986, 0.9986. So R squared is equal to R squared, 0.9993 squared, and this will be equal to 0.9986, which means 99.86% of the variability of Y could be explained by the variability of X. For the next problem, we have the values. A candy bar manufacturer is interested in trying to estimate how sales are influenced by the price of their product. The company randomly chooses 6 small cities and offers the candy bar at different prices, using candy bar sales as the dependent variable. So we have this to be your Y. The company will conduct a simple linear regression on the data below. So this is your Y and this is your X. Now, what is the estimated slope and constant for the candy bar prices and sales data? So first thing we will do is enter our entries in our graphing calculator. So, stat, edit. We will erase the previously entered entries. Clear enter for L2, clear enter for L1, L1 are our x values, L2 are your y values. So this will be 1.3, 1.6, 1.8, 2.4, 2.9. And for y, 100, 90, 90, 38, 32. Once you enter your data, stat calc number 4. And enter. So this is what we have. So you have slope negative 48.1928, y-intercept 166.3855, correlation coefficient negative 0.9618, coefficient of determination 0.9250. So if you were to use your formulas, you have the solutions here. Given the slope and the y-intercept, the equation to predict y would be negative 48.192x plus 166.386. You can easily figure that out with your graphing calculator as well. What is the coefficient of correlation for this data? Explain its meaning. Does a linear relationship between the two variables exist? We already know that r is negative 0.962. That means there is a strong negative relationship between the two variables. If we were to look back to our table, let's see how many pairs of data we have. In this case, we have 5. So n is equal to 5. So we have r equal to negative 0.962. N is equal to 5.878 for the critical value. We take the absolute value. Let me just erase that. All right. So we take the absolute value for r, which is 0.962. The critical value is equal to 0.878. R is greater than the critical value, so there is a linear relationship between the two variables. Once again, when we check for linear relationship, or if there is a significant relationship between the two, we always take the absolute value. So even though r is negative in our case, we take the absolute value, which is 0.962, and compare it to the critical value. Now, what is the coefficient of determination? The coefficient of determination is your r squared. You will take r and you will square it. So r squared is equal to r squared, basically, negative 0.962 squared. So this would be 0.925 for r squared, which would indicate that 92.5% of the variability of sales could be explained by the variability of price. If the price of the candy bar is set at $2, then what is the estimated average sales will be? So all we need to do is, first off, we check if 2 is within range, right, of the actual values. 2 is within range, so your x minimum is 1.3, x maximum is 2.9. So all you need to do is go back to your equation. If you recall, the equation was y predicted is equal to negative 48.192x. X in our case is 2, plus 166.386. So if you were to do the calculations, this would be 70. All right. So when x is equal to 2, y is predicted to be equal to 70. And this concludes the exercises for chapter 4.